what kinds of tools should data engineers be using regularly?
So when you look at the pipeline of how the data is going to be processed, or where is it coming from, where is it going, a lot of stuff that a data engineer needs to know is relational databases. That's I know it sounds very boring. Man, these relational databases have been here for 30 years. But when you look at where the data is coming from, very often it's still coming from relational databases. APIs is something that an engineer needs to know and needs to get comfortable with, because either you are going to use an API from an external source, or you need to create an API to actually serve the data internally. That's for the source and the basically the data ingestion. Sometimes people work a lot with data ingestion tools like or ETL tools like Talent or Hevo or stuff, or also tools on cloud platforms. Um, and then coming back, the processing frameworks, very often you find then something where you need to process then the data. Either this is something serverless. You find very often for simple jobs, you find something like on AWS Lambda functions, where you just create a small function and the data isn't that big that is coming in at once. So that's absolutely fine. Or if it's something bigger, where you have a framework that allows you to parallel process data, like Apache Spark, or you're going onto a platform like Databricks, sorry, uh, where you can then actually leverage that. And at the end, maybe a NoSQL database or a data warehouse, depends on your goal. But these are usually the categories: is something data ingestion, maybe a streaming tool like Kafka, I don't know, or Kinesis, then something for processing and for storage. And that's usually what you see.
Nice. So relational databases, of course, and that means things like SQL.
Yeah, yeah, yeah.
Yeah.
Yeah. Well,
Um,
I always say relational databases because people whenever I say SQL, people come back to me and say, it's just a query language. That's not a database. And it's like, yes, okay. I learned my lesson.
but yes, we're interacting often with the relational database using SQL. So that makes sense. Storing the data in relational databases, and this kind of goes back to the point that I was making near the beginning of this episode, where in ideally for a data scientist to be most easily able to work with data, or to be creating data dashboards, or a data analyst being able to work with the data, having the data structured into clear columns in this kind of relational database is key.
Yeah.
And we're like you're saying, oh yeah.
Well, it necessarily doesn't need to be a relational database. When you look at the tools that are out there right now, like let's say you have your data, and data is coming in as JSON files, or as JSON, and then you put it into files, and you make these files bigger and bigger and bigger, and then you take a tool like Snowflake, and then basically turn these onto the platform into tables. So somebody who's coming in could actually work with SQL on top of unstructured data, or tabular data. So that's what you see a lot.
Nice. Excellent. Um, and so, yeah, so relational databases makes perfect sense to me. Obviously, seems like a core skill in data engineering. APIs, we can talk about that a little bit more for our listeners in
Mhm.
case they aren't aware of what they are. So, application programming interfaces. This is like a way of interacting with computers in the same way that a click and point user interface is. But with an
Mhm.
API, instead of it being like click and point in your browser, it's at the command line. And so you can make requests to an API. So the API is it's often online and just kind of sitting there waiting for you to make some request. And then so you provide a request to it in a very specific way, and it can return some information to you. And it's interesting, you highlighted there for me something that I don't think about myself often enough, which is that data engineers are often tasked with creating these APIs for internal use. So um, APIs for external use, these have to have like a lot of documentation, be very robust. So, for example, somebody might want to take advantage of the GPT-3 model. And so they can go and use the OpenAI API to send some query to GPT-3, ask it to do some language task, and then the OpenAI API returns back to you the result of that task that you asked GPT-3 to perform.
Mm.
Um, and so, similarly, um, data engineers, like you mentioned, are often tasked with internally building these same kinds of ways of interacting in the code so that the internal data analyst or data scientist or dashboard or whatever can write this standardized request to the data engineer's API and get back some result.
Yeah, that's exactly what happens a lot. The first case, we're using an external API. It's very convenient, but a lot of people know that, especially if you use Apple APIs. I've had a few students at work, they were requesting data from Apple APIs, and Apple is just like, okay, we're changing this today. We're telling nobody that stuff changed,
Oh
and
my
then
goodness.
you're you're at the wrong end. But yeah, sometimes you need to, maybe some management tools, like just have a database for the data scientists for some model statistics or stuff, right? So they want to use that from their code. So let's spin up a database. Let's build up a simple data model and sit it in front of an API. So the data scientist does not need to work with files and stuff. So, but just the code is automatically then sending the data via HTTP requests into your database. Right? And then on the other side, maybe a user interface sits, and that uses other APIs to query that data again from that store and visualize it.
Mhm,
So
mhm. You mentioned there how APIs can change on you, like the Apple API, it can change without them giving you any notification. So, it's another part of the data engineer's job to have monitoring systems in place.
absolutely, that's one of the big things that you need to do, and or that you also, why you need data engineering constantly, because it's sometimes people think this is just a one-time thing.
Mhm.
You build that pipeline and then that's it,
It's
especially in
perfect
management.
forever.
Yeah, especially in management. Well, 20 years ago, you had that software development and you built that software, and then that's it, right? That was it. It worked for
You
years and
ship the CD.
shipped the CD exactly, and then that was it. But nowadays, a big problem is actually that the data is going to change. Like I mentioned with the API, but also it could be on the source within a relational database. Somebody does some model change and tells nobody, and then you have pipelines that actually attach to that data, and then something's going wrong. You have no idea what has gone wrong, and you need to start debugging and figuring out. And for that, you need the monitoring systems. So monitoring metrics, good metrics, and also stuff like Elasticsearch or something, where you send in errors, and or errors or warnings, send in the JSONs into Elasticsearch, and then do some research, do simple search queries, and then get to that lock very quickly. And that's
So then the data engineer might have something like Slack notifications or something that comes up if there's some kind of issues. Yeah.
could be some Slack, could be that you're firing off emails through, you create a oh man, how's it called on AWS? I think SNS, simple notification service, where once something critical is happening, you send that to the notification service, and that sends out a high priority email to a few people. And then could also be simple dashboards, where you build
Mhm.
dashboards and look at the data and keep that on track.